Look up at the night sky. It's a tapestry of stars, planets, and distant galaxies. But lurking among these celestial wonders are potential threats: asteroids. These cosmic wanderers, remnants from the birth of our solar system, hurtle through space at incredible speeds. Most are harmless, but some pose a significant risk to our planet. How prepared are we really for a major asteroid impact? The year is 2023. NASA conducts a high-stakes planetary defense exercise. The scenario? An asteroid, discovered just months earlier, has a worrisome 72% chance of hitting Earth in 2038. The exercise, while hypothetical, serves as a stark reminder of the very real danger posed by near-Earth objects, NEOs. The fictional asteroid, dubbed 2023 PDC, is estimated to be between 300 and 600 feet wide. That's larger than the Statue of Liberty. An impact from an object this size could cause regional devastation. But size is only part of the equation. The exercise reveals another chilling detail. Crucial follow-up observations of 2023 PDC are delayed. This delay, caused by the fictional asteroid's position relative to the Sun, significantly increases the complexity of the situation. It highlights a crucial challenge in planetary defense: the need for early detection. The more time we have to analyze an asteroid's trajectory and develop deflection strategies, the better our chances of averting a catastrophe. Detecting and tracking asteroids is a daunting task. The vastness of space is filled with celestial objects, making it difficult to distinguish potentially hazardous asteroids from harmless ones. Many remain hidden in the glare of the Sun, their presence unknown until they're relatively close to Earth. Even when detected, determining an asteroid's exact trajectory can be challenging. Factors like gravitational interactions with planets and the Yarkovsky effect, where sunlight subtly alters an asteroid's path, add layers of complexity to the calculations. The 2023 PDC exercise underscores the need for robust observational capabilities and advanced modeling techniques. Fortunately, we're not defenseless. NASA's Double Asteroid Redirection Test, or DART for example, successfully demonstrated a kinetic impact deflection technique. In 2022, the DART spacecraft intentionally collided with the small moon of asteroid Didymos, slightly altering its orbit. This groundbreaking mission proved that we can change an asteroid's trajectory, a crucial step towards planetary defense. Looking ahead, NASA's NEO Surveyor mission, slated for launch in 2028, promises to revolutionize our ability to detect and characterize potentially hazardous asteroids. This space telescope, specifically designed to hunt for NEOs, will scan the skies in infrared light, revealing asteroids that might otherwise be hidden from view. Planetary defense is not a solitary endeavor. It requires international cooperation and collaboration on a grand scale. Sharing data, resources, and expertise is paramount to effectively addressing the asteroid threat. The 2023 PDC exercise, with its global participation, emphasized the importance of working together to protect our shared planet. As we venture further into the cosmos, the need for robust planetary defense systems becomes increasingly vital. The ongoing efforts to detect, track, and develop deflection strategies for potentially hazardous asteroids are a testament to our growing awareness of this cosmic threat. We must remain vigilant, continuing to invest in research technology and international partnerships to ensure the safety of our pale blue dot.